when we start solving inequalities, which is what we're about to do, you don't have infinite solutions, but you have a lot of solutions, and they're limited by a value. So they're either greater than a certain value, less than a certain value, or they can be that value and everything greater, or they can be that value and everything less than it. So to mark that on a number line, we're going to use an open circle when the number that we're kind of revolving around is not included in our solution sets. So open circle marks anything greater than or less than a specific point on the number line. A closed circle means that the number that we are marking on our number line is included in your solution set. And that's going to be marked by an inequality symbol that's less than or equal to, greater than or equal to. So in example 1, I notice there's not an equal sign, so I know that I'm going to put an open circle on the 3, and then interpreting the fact that x is less than 3, I'm going to shade everything to the left of that 3. So all of these solutions, 1, 2, 1.5, 2.9, they're all going to make this over here a true statement. Any of those values I plug in. For number 2, the same thing's about to happen. We have an open circle at -1. This time the greater than portion of this greater than symbol is on the side of the x, so I know I'm looking at all the values that are greater than -1. Okay. The next 2, I have values that are greater than or equal to 4, so I'm going to mark that by including 4 in my solution set. So that's a closed circle, and to mark all the values that are greater than it, I go to the right. Number 4, now I am going to put that closed circle on -6, and I'm going to understand that this inequality is saying x values that are less than or equal to -6. Why don't you go ahead and try the next section? Okay, so hopefully you paused me so you could try this section, and you may have written x is less than 13, but it doesn't include 13 because it has an open circle. X or any variable, I mean you can use W's, doesn't matter, X seems to be my favorite. X values are greater than or equal to 7. So number 7, we've got our X values on the smaller side. We've got that filled in circle, and we're looking at all of the values that make X less than or equal to -18. And then on the final one, our X values are all looking like they're bigger than 10. But because that circle is open, we don't include 10 in our answer. All right, the most important feature of solving an inequality, it's exactly the same as an equation, with the only change is if we are about to solve and one of our steps includes multiplying or dividing by a negative number, not multiplying or dividing something that on the other side by negative, but when you're about to move that negative by multiplying or dividing it, using the inverse operation, you've got to flip your inequality symbol. And I'll be glad to explain that in class, the math behind it. It's kind of neat. So when I look at number 9, I can draw my balance line if I need to. Sorry about that. Crazy. And I get my balance line on there, right where that inequality symbol is. And then I'm going to go ahead and start this problem by subtracting 2 from both sides of this inequality. So it's the same as the 2-step. Now I have 3 x's are less than -6. I'm going to need to get rid of the coefficient. 3 is being multiplied by x, so if I would like to isolate x, my final answer has x being less than -2. It has nothing to do with your ability to, you're dividing a -6, and that doesn't change anything. So then on the number line, I've covered it up, but on the number line what we need to do is we need to mark that kind of limiting point. So we're going to have an open circle at -2. You want to try to put it in the middle of your number line, and then we need to shade to the left because we're showing all the values that are less than -2. We're good. Okay, the next problem, number 10, I'm ready to start solving. I start by subtracting 2 from both sides. Now I have x is being divided by 6, and it's greater than -3. Think of this as x being divided. That makes it easier to realize the inverse of dividing. is nothing to do with fractions. We are going to undo divided by 6 by multiplying by 6. I'll be left with x, and now x is greater than negative 18. Okay, I kind of covered up my number line, but on your number line, right in the middle somewhere, you're going to put an open circle and call that value negative 18. Then you're going to go back to your inequality and realize that x is on the larger side of that inequality, so we need to shade x values that are larger than, but not equal to, negative 18. All right, now looking at number 11, it looks like 9 and 10, but the only difference here is that flipping that I told you about. So I'm going to start by subtracting an 8 from both sides. I'm going to have negative 7, x is less than or equal to a negative 7. But on this next step, the coefficient of x is negative 7. So I am about to divide by a negative number. When we divide by a negative number, this inequality symbol now goes from less than or equal to greater than or equal to. So it flips and faces the other way. It's greater than or equal to our x, because negative 7 divided by negative 7 is 1. And we need x values that are greater than or equal to 1. So I'm going to put that closed circle, because I'm including this answer of 1. And I'm going to shade to the right, because that represents numbers that are greater than 1. And what happens here is that I can double check, because any number along here that's greater than 1 should make my inequality true. So if I forget to flip my sign, or if I'm not sure if I could test out one of these numbers. Not 1, because that's kind of my cutoff point, so who knows what's going to happen there. I would try maybe 3, 5, something you can work with. For this case, I'll go ahead and put a positive 3 in there. So if I do negative 7 times 3 and add 8 to it, okay, I get a total of negative 21 plus 8, I get negative 13. And then if I carry the symbol as is negative 13 less than or equal to 1? Yeah, it is. So I know that I've shaded the correct side of this number line with correct answers. So I have flipped it like I'm supposed to. If we move along to number 12, hopefully you're catching this. I'm going to add 5 to both sides. Okay, I have x over negative 8 is 3. I'm not going to worry about it. I can bring down the inequality symbol. Now I'm about to multiply by a negative number. I'm about to multiply by a negative number. When I multiply or divide by a negative number, I need to flip my inequality so it went from a less than sign to now it's being a greater than sign. Negative 8 divided by negative 8 gives me my x, and on this side I have a negative 24. So again, open circle, because I'm not including negative 24 in my answer. And now the x represents the larger side, which means I'm shading to the right. If I want to test this value, when I look back at my inequality up here, I'm probably going to want to choose an x value that's divisible by 8. That way I can keep the numbers friendly for checking. So think of numbers that are divisible by 8 that are bigger than negative 24. We can just go ahead and try positive 8. I can keep track of the fact that 8 divided by negative 8 minus 5 would give me negative 1 minus 5, or negative 6. Well, is negative 6 less than negative 2? It sure is, because when it comes to negative numbers, the greater the actual value is, it's smaller. Negative 6 is much colder than negative 2 degrees out. If I owe you $6, that's much more than if I just owe you $2. So just keep that in mind. But sometimes I want you to make sure you look back and see what you're about to do to variables so that you can choose a value to check that'll give you nice numbers. I'm not looking for you to show me how well you can manipulate fractions here. I want you to look at the value and say, if I put this number in, I'm going to get a solution, and I can check if this was a time I'm supposed to flip the inequality symbol. Okay, at this point you are going to want to pause. You're going to want to pause this video, and you're going to want to try a few on your own. The next slide after you're done pausing is going to give you the answer key, but you need to try this. You need to try it All the work is shown, so you should be able to look through the steps and see and make sure if you were supposed to flip the inequality symbol that you did it correctly. I hope you had a great time! All right, I've done my best to put little yellow circles on the ones you really should draw your attention. As you look through the work, you can see circles with an arrow down showing you that the sign has been flipped. The other thing to pay attention to, please, is that you have a closed circle on your number line when it says greater than or equal to, and you cut the circle open when the inequality symbol was just greater than or just less than.